Assalamualaikum warahmatullahi wabarakatuh to my fellow Sir Salihin and TSID. My name is Mohamed Fahmi bin Yahaya. I'm a third year student of Bachelor degree in Electrical Engineering Technology, Industrial Automation and Robotics. The main purpose of this video is to present my Bachelor degree project 1. Before I begin my presentation, I would like to thank my panel for their time to watch my presentation, and also thanks to my supervisor, Sir Muhammad Azmi bin Said, for his patient guidance, encouragement and advice he has provided throughout this Bachelor degree project. Without wasting time, let's get to the presentation of my Bachelor degree project. Okay, the topic of my project are design and implementation of multiple box size sorting system using Profibus Profinet industrial network. The reason why I chose this project is because most of industrial robot uses networking to communicate with other devices, and without proper communication, the robot cannot perform tasks successfully. So, this is where DeviceNet, Profinet and Profibus fit in, because it was a popular networking system for a real-time application. I will explain the presentation outline for this project. First, I will start with Chapter 1, which covers the introduction, problem statement, objective and scope of this project. Then, I will go to Chapter 2 that involves research related to project. After that, I explain more detail about Chapter 3, where all research regarding this project are implemented and developed. Lastly, I will show the result in Chapter 4. Now, I will give an explanation for introduction of this project. The industrial robot consists of robotic, electrical and mechanical system, which can be modified with many different programs to achieve consistency, precision and also accuracy when performing dangerous and cyclical tasks. This is important to increase productivity. In addition, the industrial robot usually use DeviceNet to utilize controller area network, or also known as CAN network, to act as the important technologies that cover a variety of device type. Networking is the key to the successful communication of robot with other devices. For the problem statement, there are 3 problem statements for this project, which is sorting tasks is a repetitive process and requires stable speed, so a slight mistake and delay might affect the production line. Besides that, using normal worker, it will take many hours for this sorting task, because usually human will require time to rest. Furthermore, without proper communication device, the sorting process will be difficult due to the robot does not speak an English language like us. Rather, they speak a computer language that allows them to receive and transmit command. For example, they can coordinate their timing when completing a task that they need to do together, or tell each other what action need to be done. There are 4 objectives for this project. First are to create and analyze the output of pick and place by industrial robot for sorting purposes using ABB-IRB 120, which are integrated with conveyor. To fabricate and assemble the component used for communication with pick and place by industrial robot. Next are to run rapid program for specific tasks that use in pick and place industrial robot by using Robot Studio simulation software. Last are to test run the program on actual IRB 120 to pick and place for sorting blocks from conveyor system. The scope of this project are: the project uses simulation of ABB Robot Studio before test run in actual ABB IRB 120 industrial robot arm. Simulation software is important to study the behavior of a system without building it, and this will also save costs. In contrast, the project uses actual ABB IRB 120 industrial robot to obtain the output, which is sorting box according to size. This is important to visualize the information gathered from research and ensure the actual project is a success. We have reached Chapter 2, which is research related to project. The research are done by gathering information from various sources to obtain required information for this project. Some of the project research covered are industrial robot, industrial network, sorting system and software. For the industrial robot research, at first, industrial robots are used to perform simple tasks such as pick and place. Industrial robots are a combination of mechanical system, electronic system, and programmable device. They substitute human beings for many processes such as repetitive, hard and dangerous activity. In Johanna Warren's article, released in 2008, she stated that users of industrial robotics today are categorized into three types of groups, which is handling material, process operation, and manufacture. For this project, industrial robots are typically used for sorting purposes to reduce cost, maximize performance, improve the quality of the product, and remove hazardous activity. For the industrial network research, technology used in industrial network is also beginning to be more dependent on the internet and networking standard, particularly at highest level for networking architecture. A famous researcher, Galloway, also explained in his article that technology improvement has led to a situation in which engineers are responsible for design and maintain of control networking that must be suitable for both traditional enterprise needs, such as secure network, and traditional industrial aspect that requires response time and determinism. The network related to this project are Profibus, Profinet, and DeviceNet. Based on research gathered from other sorting systems, shows that manufacturers require workers to run instruments manually for sorting and also to combine semi-automatic and manual equipment involved in sorting system process. With or without little automation, the sorting operation will require higher labor costs, low accuracy, low efficiency, and high quality control. Many projects uses IRB 120 for sorting purposes due to its agility, compact and lightweight features with superior control and accuracy. This was proven by Zhang article which are released in 2012. So, for the software research, the data gathered are stated in Connelly article, which is that by using graphical programming, edits or debug the robot system, it will create specific robot movement, simulates, also optimize existing robotic programming. This software can be used for troubleshooting, connecting to a live system, and remote maintenance for instant visual copy, then offline to allow the situation to be studied in detail. Primary advantage of using simulation software is that it can give immediate feedback for real-world system design process. The methodology for this project consists of three main parts, which is first, the part of designing the system. Second part is program of robot arm by using rapid code in Robot Studio. Third is troubleshoot, improvement and optimization process that are done to ensure the project achieve desired expectation. For project design, it involves circuit design of this project. The circuits are done to show the simple connection of DSQC652, which are connected with a PLC and IRC5 by a DeviceNet cable and form a network called a CAN network. As we can see, at the DSQC, there are switches connected as input and LED connected as an output. These simple circuits are built based on gathered research to study the connection pin of each device and test to trigger the output and input successfully. After that, we must use Robot Studio software to set up I/O for DeviceNet. The figures shows that digital input is set for switch while digital output is set for LED. Network use is DeviceNet and device set to DSQC652 because this project is using DSQC652. This setup can also be implemented to trigger the gripper of the robot. The sensor is set as input and the gripper is set as an output. Flow of DeviceNet I/O setup before this are shown in this flowchart, where the system is start, then IRC5 will wait for a command from PLC. If PLC switch requests to turn on LED, then IRC5 will receive request and process to see if the command is acknowledged by IRC5 or not. If not, IRC5 will continue to wait for command from PLC. If yes, then LED will turn on. Next, other than setup for industrial network, we also need to understand how to set up the robot and how to build the smart component for robot gripper. A simple pick and place are done in Robot Studio software. The workflow for programming robot is select robot and type of a network, then create and model station. After that, create target and part. Then insert input and output for gripper. When all setup of robot is done, then synchronize to repeat so that we can edit coding. When editing is done, synchronize to station, then we can simulate the robot to see the robot movement. Here are the rapid code programming for a simple pick and place. The rob target are set by teach target function in Robot Studio that allow us to position the robot at desired coordinate. Proc main are required so the robot move along the main path according to sequence. Lastly, probe part 10 that can be used to edit each target speed and zone to ensure the robot movement is smooth and accurate. So, the preliminary results are obtained from project development in Chapter 3. The result part will show the model of the DeviceNet network, industrial robot in the Robot Studio version 6.05 software, workspace, and the implementation of certain tasks such as pick and place that are integrated for sorting purpose. Ladder diagram of PLC program indicate when a digital input such as switch is set to on, PLC will communicate with the SQC and IRC file controller to trigger the LED that acts as an output. After that, the IRC file controller will continue to wait for command from PLC. The other model are testing of robot pick and place using IRB 120 in Robot Studio software. So, as you can see, now we are getting to Robot Studio and PLC simulation result. The simulation result shows that setup of simple DSQC circuit connected with switch and LED as I/O is a success. As we can see, the digital input and output are triggered in Robot Studio and PLC software. When switch is on, LED will light up. Besides that, the other results are gained from simulation of a simple pick and place where the robot are success to pick and place the object from one place to another. As you can see at this project, this is an example of pick and place done by industrial robot IRB 120, which are not using the normal gripper but using the vacuum gripper type. So the objects are successful in pick and place from one place to another. After understanding how simple pick and place are done, then we can research more to integrate robot arm with a moving conveyor. These are the expected results from this project. Is the sorting system are integrated with a moving conveyor are built successfully. Next, communication between all devices are established and achieve desired output. Then, the sorting system robot arm are able to sort multiple box size, and more research and development will be required to achieve the expected result. Now, as a conclusion, the implementation of this project are designed to help making it easy for sorting purposes and provide information for better understanding of industrial communication between different types of devices. Besides that, more research and development will be done and be implemented in PSM2 or Bachelor Degree Project 2 to achieve the objective of this project and ensure this project is successfully designed to achieve our objective. These are some main references obtained from research for this project to help better understanding of this project structure, how each device are set up, and previous project comparison, and also software explanation for the information of networking system. Next are the Gantt chart that are built for this Bachelor Degree Project 1. This project requires Gantt chart in order to perform a management of control and planning for this project to ensure that this project follow our deadline. Besides that, the progress of the project can be seen from the Gantt chart, and also the Gantt chart will help to set a timetable for a certain task execution and also ensure that all work are done before due. So that's all from me. First and foremost, I thank God the Almighty for countless blessings. Then I would like to thank my panel, Sir Mohamed Salihin and TS Zaidi, and also my supervisor, TS Mohamed Azmi, for his excellent guidance. And also thanks to my friend and family that give a lot of guidance and support to make sure this project are done successfully. Also thanks to all viewers of this presentation video. I hope you guys are happy with my presentation and it helped to increase our knowledge. Don't forget to share and like this video. Thank you.